Alrighty, ladies and gentlemen, here is the second video of Chapter 7, and that is on the continuation of the Law of Sines, but it is a special case of the Law of Sines, and that is what we call the ambiguous case. So, the ambiguous case brings up a topic that you guys kind of discuss in geometry, and this is what's going on here. It says if you are given two angles, then there is always one unique triangle formed, but in this lesson we're going to extend the Law of Sines to solve triangles where we are given two sides and an angle opposite one of these sides. In this type of situation, there is not always just one triangle, and this is why we call it's ambiguous, okay? Because there's a couple of different options, it's up in the air. Now, everyone always laughs at this. When you see this relationship, so if you guys remember back to geometry, you had side, angle, 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 side, and then there was the big no-no one, ASS. In this chapter, if you see that, you got to worry. That is the ambiguous case. Okay, so anytime you see ass, go ahead and chuckle. You've got to worry about the ambiguous case. Okay, that is the only time though. Okay, and we'll show you what we mean by that here in a second. So this is not going to make a whole lot of sense, but these are some really nice step-by-step processes to take during when you have this ambiguous case or ASS. So step one is going to be first draw your triangle, and then it's going to say find the angle opposite the other given side. Okay, if your sine ratio is greater than 1, no triangle exists. Okay, step two, find the supplement of this angle by subtracting from 180. If the new angle you get plus the original angle given is greater than 180, we can only have one possible triangle. Okay, if the new angle plus the original angle is less than 180, two triangles exist. Okay, here's what the ambiguous case eventually boils down to. If you guys remember the inverse sine restrictions, inverse sine always gave us something between negative, and I'm going to do it in degrees just because that makes a little more sense, between negative 90 and 90. But sine is positive in quadrant 1 and in quadrant 2. So what we're trying to figure out is it possible to have this angle and this angle forming two separate triangles? Okay, so this is kind of a visual example of that. The one where there's no triangle because you don't have enough of a length to connect that no matter how you do it. There is a special case with one unique triangle, and then there is the ambiguous case where we have two of them. And the idea here is that I could have this leg right here and this leg. They're the exact same leg. It's just a matter of, do I sweep it out this way? Will it form a second triangle? Okay, so here is what we are going to start with example 1. Draw yourself a picture. Again, they don't have to be to scale. Label it ABC or whatever is given to you. I'm telling you that angle A is 30 degrees, opposite A is 2, and B is 6. Okay, so this is an example of you've got angle followed by side by side. So this is angle, side, side. I always put a frowny face here because now we've got a little extra work to do to solve this. Okay, so step 1, if you remember from our process here, is always find the angle opposite the other given side. Okay, so I could set this up and go sine of 30 over 2 is equal to the... Did I label something wrong here? Yes, I did. Oof. That would have been bad. B is 6, not C. So I'm going to say find the angle that is opposite the other given side. So I'm going to say sine of 30 over 2, that's given to me, is equal to the sine of B over 6. Okay, we cross multiply, so that's going to give me 6 sine 30 is equal to 2 sine B. If I divide by 2, I'm going to get the sine of B is equal to 3 sine 30. Now, if you were to type that into your calculator, sine of 30 is a half times 3. You could simplify this all the way down to 1.5 is equal to the sine of B. And we should automatically be thinking that, hey, there is no angle where a sine ratio is going to be greater than 1. But if you have a calculator at home and you don't trust me, take the inverse sine of 1.5 and your calculator is going to give you an error. This is where we stop at step 1. Where if your sine ratio is greater than 1, no triangle exists, because if you tried to take the inverse sine in your calculator, you would get an error. So this one is no triangle exists. Okay, so that's one of our 3 options. Let's take a look at the next one. So I've got triangle KMN Yep, KMN. So KMN. I know side K is 9.1, little m, side M is 12, and angle K is 35 degrees. So if we look at this, I've got angle, side, side. I'm not going to write it every single time here, but that's what we're going to run into every time in this chapter, or in this section, I should say. Now, I do want to point one thing out because maybe some of you guys are thinking, why is that angle side, side? If I move this 9.1 over here, this is no longer angle side, side. This would be side followed by angle side. It's got to go in order there. Okay. So let me erase that, put it back in the spot. Okay, step one, always find the angle opposite your other given side. So I could set up sine of 35 over 9.1 is equal to the sine of m over, what do we got, 12? Okay, so this is going to, I'm going to skip a couple of steps here. Remember, we're just cross multiplying. This is going to give me 12 sine 35 over 9.1 is equal to the sine of m. From here, you would need to take the inverse sine of that, which is going to give me angle m is equal to 49.1 degrees if we go to the nearest tenth. Okay, box that for me. That is one of our answers. Now, if we go back to our steps here, it says if you get that first one, step two is find the supplement of this angle that you just found. Okay, so what I'm going to do off to the side here is I'm going to find the supplement of that by taking 180 minus 49.1 is equal to 130.9. Okay, now here's essentially what's happening there, guys. When we took the inverse sine, we got a reference angle of 49.1 and 49.1. Okay, I know that this one's going to exist because it's an acute angle. The question is could I possibly have a triangle with this obtuse angle of 130.9? And the way that we go about that is if you look at your steps, add on your original angle, and then we have two separate possibilities. So I got 180 minus 49.1 give me 130.9. I'm going to go plus 35, and that's going to give me 165.9. Okay, which means this would be like one of my angles. This would be a second angle, and the question now becomes, do I have enough left over to make a third angle? And the answer is yes, because there's three angles in a triangle. Or there are 180 degrees in a triangle with those three angles. Okay, so this is our scenario where there are going to be two triangles that exist. As soon as you see that, I split this up. This is triangle 1. This is going to be my work for triangle 2. Okay, so now at this point, you could come back and finish solving the one on the left. It doesn't really matter. Over here, I'm going to just redraw a triangle and just show you how this is going to be different now. So I'm going to go K, M, N. The given information does not change. This is going to be 35. M was 12, and then this was 9.1. Now, what we found here in the first one, angle M, was 49.1. Here we said it is possible that you could have a 130.9. Okay, so we've got a couple of different things left to find. I'm going to go back to my first one right here, and I'm going to finish this one out, and then we'll come back and deal with the second triangle. Okay, so off this one, right away I could find angle N by saying 180 minus 35 minus 49.1. Okay, because that's just the third angle I'm trying to find here. That gives me 95.9 degrees. Okay, that's angle N. So from there, I'm going to erase this. Oops, that's not what I wanted to do. Just write it in there, 95.9. So now I could say the sine of 35 over 9.1 is equal to, I could go sine of 95.9 over side n. Now, technically this value right here has been rounded because we rounded way up here and then we took 180 minus to get this. really, you should not round this value. You should use the huge long decimal. It's like 95.87 something. Since we're in a unique situation here, I'm not going to be as picky with that, but really we should not ever round until the very, very end here. Okay, if I solve this equation, you guys have done this in the first section, and we did it a couple times today. I'm going to skip those steps. I'm going to call this n is equal to 15.8. Now, just because every year I have people who will do this problem and they'll end up with m's, n's all over the place, it's a... What just happened? Is this still recording? Yeah, that was weird. What you should do is you should come back and do like subscripts on these. N1, N1, M1. Okay? So let's come over to this one. This one was where angle M2 was equal to 130.9. Same idea as the last one. I could go and find angle N by taking 180 minus 35 minus 130.9, which is going to give you 14.1. So angle N2 is equal to 14.1. Again, remember that's a rounded value. So technically we should keep the whole thing, but again, I'm not going to be super picky. So really the only other work I have here to do is go sine of 14.1 over n is equal to, start off with the given stuff, sine 35 over 9.1. Cross multiply, this is going to give me, I'm going to call this n2. So n2 is equal to, and I might as well just come over here and write it, n2 is equal to, we should get that to come out to be 3.9. Okay, by cross multiplying and then dividing by sine 35. So n2 really is 9.1 sine 14.1 over sine 35. And again, that just comes from cross multiplying and solving, guys. So really this is a 6-point question. You got to find 3 pieces for each one. Okay. So the second one is the exact same example. Now, typically what I do is I do this on the active board, and what you're going to see is an actual representation of these two triangles. And what I normally do is I take this one here and I drag it over the top of this one, and you guys can see that all of our starting information matches up perfectly. I do just want to point out, like, if I were able to do that, this angle and this angle match up perfectly. This side length of 12 is the exact same length. They line up perfectly. And MN is 9.1 and 9.1. The only thing that's changed is where does this 9.1 go? Instead of like dropping it right here, what I did is I swung it out here, which is elongating that, which is making this angle right here of 130.9 larger. Okay, so that is the kind of visual representation of those two triangles. You guys never have to draw them to scale, and in fact, I think that causes more problems than anything, so I would recommend you don't. Okay, that was a doozy. Let's try another one. Number 3, we've got what triangle looks like A and B, so technically you could pick whatever you want here. We'll just do ABC. So A, B, C. I know what A is 114, B is 32, and A is 21. So first step, find the side opposite find the angle opposite the other given side. So I'm going to say sine 114 over 21 is equal to the sine of B over 32. This is going to give me the sine of B is equal to 32 sine 114 over 21, which comes out to be sine of B is approximately 1.4. That's a problem. Can't have an angle where a sine ratio is larger than 1. So this one is no triangle exists. So that one's nice. So far we've seen 2 triangles. We've seen no triangles. Let's take a look at this next one, and we will show you where only 1 triangle can exist. Okay, so example 4. I'm going to draw a triangle ABC again. ABC. C is what? 47. Side C is 20. Side A is 12. So I got to find this angle right here first. So I'm going to say sine of A over 12 is equal to sine 47 over 20. This is going to give me that the sine of A is equal to 12 sine 47 over 20. Now we've got to take the inverse sign here. So A is equal to the inverse sine of all of that. This should give us that A is approximately, I don't know why I went to the nearest degree here, but I did. 26 degrees. So I'm going to do that over here just so we stay a little more organized. A is 26 degrees, guys. Make sure that you're able to get this in your calculator. And if we need to talk about options of, or spend some time talking about typing these in, because I don't know how many of you have graphing calculators, we sure can. But make sure you're practicing that. Okay, so this one, we did have a triangle. I know for sure at least one triangle exists. Now it's a matter of, could we possibly have a second one? Okay, so what we do is we take the supplement. I go 180 minus 26, the angle I found, and that gives me 154. Okay, so my two options for that angle are it's either a 26 degree angle or it's a 154, which again just comes down to is it in quadrant 1 or quadrant 2. If I do this, that would mean that if I had a 154 degree angle and I go plus 47, that is going to be larger than 180, which means there's nothing left for my third angle. So only one triangle exists. Okay, there's not enough left over for us then. So now all we have to do is finish solving this first triangle. So this is even nicer than the two triangle one because we only have three things to find. So A is equal to, and I should say angle A is equal to that. We could then right off the bat find angle B, which would be 107 degrees. Then the only last thing I have is to find side B. Okay, so B we said was 107. Again, I'm assuming I don't have my calculator on me. I'm assuming that value is rounded. Technically, we should not use a rounded value, so just keep that in mind. So if I want to find side B, I could go sine 107 over B is equal to sine 47 over, what, 20. So B is going to be equal to 20 sine 107 over sine 47. And then you just got to solve it. And that should give you that B is approximately 26.2. Okay. How many more examples do I have here? 5 and 6. Okay, if you guys would like, go ahead and try the next couple on your own. If not, you can just continue following along here. So I've got triangle ABC here again. A is 39, C is 45, and angle C is 97. Now I've kind of skipped over this in the last couple, guys. Remember, the only time we got to worry about ambiguous case is when we have angle side side or ASS. We have that here, so keep that in mind because when you get to a test, it's not always going to be angle side side. And if you go and you start finding a second triangle for stuff that doesn't have a second triangle, you're going to lose a lot of points, okay? Remember, this is the only time that we have to worry about this. So, let's do it. Find the angle opposite the other known side. So my first goal is going to be to find angle A. I'm going to go sine of 97 over 45 is equal to the sine of A over 39. If we go through that, I got A is 59 degrees. So my next option, or the next thing I need to do, is check to see if a second triangle does exist. So let's go 180 minus that 59. 180 minus 59 is equal to 121. So this is like my other possibility. It's 59, but could 121 possibly exist? So we add on the other existing angle of 97. That is greater than 180. So only one triangle exists. Okay, so again, kind of nice. We don't have to go and find 6 things. So I got angle A is 59. No, this scares me that I messed something up here. Why do I have... Let me just type this in real quick. Okay, I don't know why I rounded that. So this was 59.3 degrees. So angle B, take 180 minus 59.3 minus 97, and we get 23.7. Sorry about that, guys. Okay, so 23.7 is angle B. Again, that is a rounded value. If you guys are following along on your calculator, technically this value was 59.33979512. And that's what I should be subtracting from 180. Okay. So the only thing I have left to then do is find, I'll plug this in my 59.3 from earlier, I've got to find side B now. So I can say the sine of 23.7 over side B is equal to, always start with what we had, so let's go sine 97 over 45. If we do that, you'd get B is equal to, that should come out as about 18.2. So I'm going to come over here, B is equal to 18.2. Okay. So one last one, and then I think we're done, right? Yep. So let's draw triangle ABC. I've got A is 7, B is 10, A is 32. So I'm going to start. Sine of 32 over 7 is equal to the sine of B over 10. If we go through and we solve that, you should get angle B is equal to 49.2. Okay, so come off to the side then. We got to check, does a second one possibly exist? So I'm going to go 180 minus 49.2, which is going to give me 130.8. Okay, so these again are my two possibilities. Add on the other 30, or the other angle that I was originally given, which was 32. That is going to be less than 180. So we've got two triangles here. Two triangles exist. Where this one right here is my other value that could be angle B. So I'm going to say this is angle B1 is equal to 130.8 degrees. Now you could call this one B1 and B2, just as long as you keep them separate, guys, so I know which ones I'm looking at. And now it's just a matter of solving both of them. So before I mess something up, I'm going to just redraw my triangle here with everything I know. So ABC, this is 32, 7, and 10. And then we said B on this one was 130.8. B over here was 49.2. Okay. Angle C on this one, by taking 180 minus the 2, is going to give me 98.8. And then the only thing I have left to find is side C. So this was my 98.8. So I could say sine of 98.8 over C is equal to sine 32 over 7. Typing that into my calculator after you get done cross multiplying would give me that this is approximately 13.1. So there's 3 of my answers. Over here, if I take 180 minus 130.8 minus 32, this gives me angle C1 is equal to 17.2 degrees. Okay, and then I've just got to find actual side C1. So this was my 17.2, so I can go sine 17.2 over, we'll call it C1, is equal to sine 32 over 7. Okay, and if we solve that, you should get C1 is approximately 3.9. So there are my 6 answers, 3 for each triangle. This is the biggest thing I want to get in your guys' head, because the next video is law of cosines. So you're going to have regular law of sines, you're going to have law of cosines on a test, and you're going to have the ambiguous case all mixed up. The only time we need to worry about ambiguous case is when you got to ask. Okay, that one got a little lengthy. I apologize. Here is your homework. Make sure you guys are practicing these.